So let's get back. So basic rules of differentiation. So if y is a function which is made of sum or difference of certain functions, then the derivative of y with respect to x is the derivative of each of these functions with respect to x. So, and while the sum or difference remains as it is. So it is term by term differentiation. Now, if we multiply a constant to a function and then differentiate it, it is same as the derivative of the function multiplied by the constant. Next, we have this product rule or UV rule of differentiation. This is the third one, which is very important, UV rule of differentiation. Okay, so derivative of u into v is derivative of u treating v as constant plus keep u as constant and multiplied by derivative of v. So take one function, differentiate it, keep the other one as constant. Okay, that is the UV rule. Now, quotient rule. This is product rule. Previous one was product rule. This is the quotient rule. Now, quotient rule, the denominator will be v square. The denominator square, basically. Then we'll get v, the denominator, multiplied by the derivative of the numerator minus the numerator into derivative of the denominator. Okay, this we have to remember. Very important. Next, we have chain rule of differentiation. So this was product rule, this is quotient rule, this is chain rule. So in chain rule, if y is a composite function of u and v and w, then derivative of y with respect to x will be derivative of u with respect to the inner function v, then derivative of v with respect to the inner function w, and derivative of w with respect to x. In other words, we write this as u dash of v of w of x times v dash of w of x into w dash x. This is the chain rule of differentiation. So we use these 5 important results in finding derivatives of any function. So today I don't have objective questions, but I'll give you questions on each type, and these questions I've already loaded in the Moodle for you to practice again. I will not do all the questions, but I will make you do some of the questions, and remaining questions you should solve by yourself. So this is the first type. Using these 5, differentiate the following functions. Using these previous 5 properties, differentiate the following functions. Now the first question, y is log x cube plus 3 times sine inverse x plus kx square. Okay. So when we differentiate, first of all, we will simplify this. We can write this as 3 log x plus 3 sine inverse x plus kx square. Now, when we differentiate with respect to x, we get dy by dx is now derivative. This is a constant. Actually, I'll not repeat this, but first problem I'm writing again and again. I'll not repeat this. So derivative of all 3 functions, sum of the derivatives. Now this is 3 times derivative of log x, which is 1 by x, plus 3 times derivative of sine inverse x, that is 1 by under root of 1 minus x square, plus k comes out, and derivative is the derivative of x square is 2x. So dy by dx is 3 upon x plus 3 by under root 1 minus x square plus 2kx. So this is the solution. Please check your result. Okay. Y is log x upon x plus e power x into sine x plus log x to the base 5. So find the derivative for this function. Okay. So dy by dx, again by the first law or the first rule, it will be derivative, the sum of the derivatives of these 3 functions. Now the third one I will write slightly differently to make it easy. I will write this as log to the base e of x by log to the base e of 5. Okay, reason? Since log a upon b, log a to the base b is same as log a to the base e upon log b to the base e. This is change of base rule in logarithms. It is not just e, you can change it to any base. 10, log a to the base 10, log b to the base 10, like that. So it is log x to the base 5. I'll write as ln x, or natural logarithm of x by natural logarithm of 5. Now the first one is a u by v quotient rule. So derivative will be denominator square, the first term, then denominator into the derivative of the numerator minus the numerator into the derivative of the denominator plus. This was the first term. The second term of differentiation, it is u into v. So derivative of u keeping v constant plus keeping u constant multiplied by derivative of v plus this log 5 to the base e in the denominator of the third term is a constant, so it will come out and it is derivative of log x. So this is therefore dy by dx is, now derivative of log x is 1 upon x minus log x into 1. When we write like this, it means it's a natural logarithm. When we are just writing without any reference, it is natural logarithm. Plus this is derivative of e power x is e power x, so e power sine x plus e power x into derivative of sine x is cos x. And then derivative of log x is 1 upon x multiplied by this constant 1 upon log 5. So on simplification, we get x, we get 1 minus log x upon x square plus e power x into sine x plus cos x plus 1 upon x log 5. This is the derivative. Okay. Please check with the answers you have got. If you have not got this, there's some mistake in the calculation. Now, derivatives are generally straightforward rules. It is not difficult. If we just keep following the rules properly, you will get the right answer of the derivative. Now, let us do chain rule. We'll have to do 2 problems on chain rule. It is e power tan inverse x the whole square. So, how many functions are involved? How many? Yes, good. Good. So, find the derivative. Here, there are 3 functions involved. Let me explain the 3 functions. Okay. First function is e power x. The second function is x square. And the third function is tan inverse x. So if it is, y is e power u. Now u is v square and v is tan inverse x. So it is like this. There are 3 functions involved. So now let us differentiate. Differentiating with respect to x. differentiating with respect to x, dy upon dx. Now, the derivative of e power tan inverse x the whole square will be the first function, e power anything, derivative will be itself. Then we multiply with the derivative of tan inverse x the whole square. So you get e power tan inverse x the whole square into 2 tan inverse x, because now this is x square form. So it will be 2x into derivative of tan inverse x. So this is the chain rule, 1 by 1. So e power tan inverse x the whole square into 2 tan inverse x, and derivative of tan inverse x is 1 upon 1 by x square, 1 plus x square. So this is the answer. Okay.